Hi guys. Let me know if I'm properly audible.
Hi guys.
Okay, so I think I am audible. Thanks, Utkarsh. So let me share my screen and we are going to discuss questions based on artificial intelligence subject. So in this artificial intelligence subject, you have three topics, right? Three parts mainly, if I'll discuss here. One part is search, right? And then we have another part that is uh, your logic, right? And then you have your third subject that is your reasoning with uncertainty. Reasoning with uncertainty. Uncertainty. So you have these three topics mainly. So in this session, we are going to cover we'll try to cover these particular sessions, particular topics, and in the next session, we are going to cover questions on search and reasoning with uncertainty. Okay, so let's start with questions one by one, and I suggest you also try all those questions with myself, so that you would not you would know how to solve questions as well. Okay, so let me start with this question. So this question is I have taken from Gate CS. The logic questions I have taken from Gate CS because in discrete mathematics there are different type of questions they have said, and also I have taken Gate questions from 2024 DA as well, right? So let's suppose we have three statements, PQ. We have two statements. P statement is good mobile phones are not cheap. Q is cheap mobile phones are not good. And then we have three statements. L is P implies Q, M is Q implies P, N is P is equivalent to Q. Now, which of the following about L, M, and N are correct? Can anyone tell me which of them is correct? Okay, just try this question once, guys. Think about it and let me know what can be the answer. Guys, we haven't uploaded the AI lectures on this channel, on this YouTube channel, right? So we haven't uploaded that. There's no playlist for AI, but there's one playlist for machine learning. Okay, so if I'll see, let's say good mobile phones as I'm taking good mobile phones as X, good mobile phones, right? And if I'll talk about cheap mobile phones, I am taking that as Y, right? Now, this P statement says that good mobile phones are not cheap. So that means if mobile phones are good, then they are not cheap. X implication negation of Y. And then we have Q statement. Q statement says that cheap mobile phones are not good. That means Y implication negation of X. We have this statement. Now I have to check that out of this L, M, and N, which of them are correct. So L says that P implies Q. That means this statement. And M says that Q implies P. This statement. And N says that P is equivalent to Q. Right? So what would I do? I'll draw a table for, I'll draw a truth table here. So first I'll take X and Y. So how many combination possible? True, true. Let me write down it properly. Just give me a minute. Let's take the statement X, Y. True, 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 false, false, true, false, false. Right? So these are the cases. So we have to find out the truth value of P and Q. So P is X implication negation of Y. We know that P implication Q, or let's say A implication B is false only when V is false. Otherwise, it would always be true, right? We know that. So what would I do? So P, if I have to find out truth value for P, that means I have to find out truth value for X implication negation of Y, right? So now negation of Y would be Y gets negated, true becomes false, false becomes true, true becomes false, false becomes true, right? So true becomes false. So this statement would become false. true becomes true. True. False implies false. That is true. Because A implication B is false when A is true and B is false. Otherwise, they would be true in every case. And this would also true. So we get only one false. Now, if I'll find out A implication negation of X. Now, in this case, this would be false. This would be true. This would be true. This would be true. Right? So everyone gets this. Now you can check what is this L statement. Let's find out P implication Q. So P implication Q, we'll get true, 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 true. Why it is true? Because we do not have any case true implies false, right? So that's why. Similarly for L M statement, M is Q implication P. I have to do Q implication P. So it would again gives me true, 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 true. And also I have to check N statement. N says that P is equivalent to Q. And I can say that they are equal, right? So they are equivalent. Equivalent means that they would take same truth values at the same time. So you can see that L is true, M is true in every case, N is true. So that means L, M, and N all are true. So option D is correct here. Does everyone get it that why option D is correct? Let me know, guys, if on YouTube as well, guys. Just let me know if there is like if this question is clear. Okay, so this is simple question. Now let's see another question. Yeah, this is one of the question. They are asking what is a converse of the following assertion. I stay only if you go. So you have to find out converse. Okay, if I'll go back to this question one more time, I have just find out the truth table here, Prashant. Okay, Ajay, we are going to come on the topic variable elimination. We are going to solve questions based on that. Then we can go through that particular topic. Like, and Prashant is saying, can you revise one more time this particular question you are asking, Prashant? So if you would see here, we have two statements, P and Q. I have taken good mobile phones are not cheap, right? So I have two statement, X and Y. X statement, I have taken that mobile phones are good. Y statement is mobile phones are cheap. Now in this P statement can be converted as if mobile phones are good, then they are not cheap. So that means if mobile phones are good, that is X, and then they are not cheap, implication negation of Y. Right. For this particular question, there is no short trick because you can see that uh, uh, if you would write down here X implication negation of Y, right? Like one thing you can do here, let's take this L statement. L statement is capital P implication Q. Now you can write down this as X implication negation of Y, implication Y implication negation of X, right? And if you guys know, P implication Q is basically negation of P or Q, right? Do you know this formula? This is a formula for equivalence. Now you would do write down here negation of X or negation of Y, right? And this is what? This is implication again. And Y implication negation of X would become negation of Y or negation of X, right? Now you can open this implication as well, but again, this is also a longer method. Or negation of Y, or negation of Y, or negation of X. Right now, you would take this negation inside. Now you are going to use De Morgan's law. What it would become? Negation, negation X, and negation, negation Y. Right? And then you would write down or negation Y or negation X. Now you can see that negation negation X, it would become X and Y, or negation Y or negation X. So you can see that this statement would always gives you true. If XY is true, this would be true, right? And it or does not matter. If XY is false, this would be true. But if X is true or Y, one of them is true, this the second part would be true, right? So that's why then it got like then you can solve it. But yeah, that is again also not a short trick if you are going to use equivalence as well. I hope this thing is clear. Okay, if this thing is clear, then we are going to move to next question. I stay only if you go. Just tell me, guys. Just try this question once, guys. So this question says that I stay only if you go, right? So what does this mean? Uh, what does this mean? I stay only if you go. So if I'll take here, I stay as P. Let's take I stay as P and you go as Q, right? What would be the meaning of this statement, or how I can write down this statement? P implication Q. Because of this only if I have P only if Q, P only if Q, it is represented as P implication Q, right? It is represented as P implication Q. So I stay only if you go is represented as P implication Q. Now I have to take a converse. So what is a converse? If we have P implication Q, it gets converted into Q implication P, right? It gets converted into Q implication P, right? So this is my converse, right, guys? This is my converse. So it says that if you go, then I stay. If you go, then I stay. Now tell me which of the option is correct. Guys, tell me which of the option is correct now. Which of the option is correct here? Everyone in chat section, guys. See, guys, if you go, then I stay. So obviously C and D are not correct because they are negation. They have negation. Now, one is if I stay, then you go. But you can see that the statement here is if you go, then I stay, right? And if you would see option A, what option says that I stay if you go. So it makes the same sense as this statement. So option B is incorrect. Only option A is correct. Just tell me, guys, everyone gets it why option A is correct here, not B and D. First of all, we have to understand, guys, we have some statement. First is P implication Q. If I'll talk about converse is basically Q implication P. And if I'll talk about inverse, inverse is basically negation of P. And the contrapositive of this particular statement is negation of P, implication, negation of Q. So you have to remember this. Right, right, right. C would be contrapositive. Right, right. Right, Aj. Okay. Now, let's see this network structure. So this is a Bayesian diagram given to us, right? So this is a question, reasoning with uncertainty on the topic. So this is a Bayesian diagram given to us. You can see that here J is dependent on G is dependent on B, I, and then M is dependent on I, B is independent on I. So they are saying that which of the following are asserted by network structure. Is they are asking for out of first, second, and third, which are true. Tell me, guys, if I'll talk about first, probability B, comma I, comma M is given as probability B, probability I, probability M. Is this is true? B, I, and M. Would it be true? First part, guys, would it be true? No. right? Everyone, first is not true. It is false, right? It is false, right? It is false. Now, if I'll talk about probability J given G comma I, right? What it would be probability J, second one is true or false? Second one, guys. Because if I'll, first one is incorrect, guys. Let me explain the first one part as well. Probability B comma I comma M. How would you write down this probability? So you would write down probability B given I into probability M given I into probability of I. If it would be written like that, then it would be true, right? Everyone. Now I just want to know for the second one, probability J given G and probability J given G comma I. Is it correct? What about B, second part, guys? So let's say if I'll talk about second part, probability. Let's say if you need to find out probability of J, let's take all the values G, B, I, M. I can write down G, comma B, comma I, comma M. Now you would see that what are the values or what are the variables that are in Markov chain of J. So if you would see the Markov chain contains only G, right? So it would become probability J given G. So it does not matter if we have B comma I comma M, and you also can write down this as J given G comma I. That would be same, right? Because what is probability J given G comma I? That would be again probability J given G. So that would be correct here, right, everyone? Because if you would write down this as what it would be probability, you have to find out probability of J given G comma I. If G is already given, let's say G, you have given what G can take. G can take here values true and false. If G is already given true, it doesn't matter what value I will take. Do you get it, guys? Okay, let me explain this problem again. Just give me a minute. Let me erase it. See, basically, if you have studied joint distribution, right? So let's suppose we have this I, and then we have this G, and then we have this J, right? So now let's suppose J is dependent on G, G is dependent on I. I have to find out probability J given G comma I, right? So let's suppose G is given to me true. G is given to me true. No matter what value I would take, no matter what value I would take. If G is true, probability of J would be zero point 0.9. If G is given, G is false, we have given, then probability would be zero point 0. So it doesn't matter if we have given I or not, if they are asking for the probability of J. If G is not given, if they would ask probability J given I, then that is a different thing because G is not given. Then you have to write down probability J given G into probability G given B comma I comma M. You have to write down all these things on which this, just a minute. Just give me a minute, guys. I just by mistake, my screen stopped sharing. Just a minute. Yeah, now I suppose my screen is visible. Okay, so that's why. Okay, just a minute. What happened? Yeah, let me share the screen. Now, I suppose it's visible. Now, probability. Okay, so now you would see that if they are asking probability J given I, then that would be different matter because my probability of G depends on I, P, and M, all the variables. But here, what happened? We have already given G. So it doesn't matter what value of I'll have, it would always have probability G given I, J given G. Do you get it, guys? Vindhya, Arvind, do you get it that why this is true? Second part. On YouTube, guys, everyone gets it why this is true. Let me know. J does not, Arvind is saying that J does not depends on I, so no value of I matters. Yeah, but you cannot say that J does not depends on I. J does not depends on I when G is given, right? If G is given, then J does not depends on I. Let's suppose you do not know the value of G. Then J depends on the value of G and G depends on I. But I have already given G. Let's understand this by this way. Let's suppose, can I write down one example here? Okay, let me write down one example here. So let's suppose I do not sleep properly. I do not sleep properly as A, right? And B as I have headache. I have headache. C. I'll take medicine, right? And let's take D. I have to rest, right? So these are four statements. Just understand this. We have four statements. A. So if I do not sleep properly, then I'll have headache, right? If I'll not, if I have headache, then I have to take medicine. If I'll take medicine, then I have to take rest, right? So this D depends on A, B, C, right? Now you can write down if you want to know that D exists or not, what would be the value that D would happen or not. It would depend on A, B, C. That because I'll take medicine or not, I'll have a headache, I do not sleep properly. So let's suppose I'll not sleep properly, then I have headache, then I'll take medicine, then I have to rest, right? So it is given to me. But let's suppose I'll say that what is the probability that D given C? I'll say that probability D given C. So I know that C is true, that I have to take medicine. I have to take medicine. It is true. Then if this is true, then I have to rest. Then I have to rest. So now D completely depends on C. It would not depend on A and B because I know that C is true. If I know the value of C, if C is true or false, and what is how I read this? D given C. If I know the value of C, then I can say that probability D given C is same as probability D given A comma B comma C. Because now you would say that A and B does not matter what value it would take because it is now depends on the value of C. But if I write down probability A comma if they are asking probability of D, I'll write down this probability of D as probability D given C into probability C given B into probability B given A into probability of A, right? I have to write down like this as a chain rule. But here, because I know that the value of C already given, probability D given C they are asking. So I can write down this as like this, probability D given A comma B comma C, right? If I'm taking our medicine, so this means we are talking about conditionally independence, right? If I know that this value is true, so no matter what is happening here, because of A and B, I was going to know the value of C, but I already know the value of C, right? Here given C we have taken, so no matter what values A and B would take, it would not change the value of D because C is already given. So that was happening in the second part. Now let me know if this thing is clear, guys. Let me know, guys, in chat section as well if this thing is clear. Everyone gets it, guys. Okay, now let's come to the third part. So when I was talking about, let's say I have a here, if I'll say I need to find out probability M given let's say all the variables g, b, I, j, whatever the variables I have, g comma b comma I comma j, right? So it would always comma I comma j, right? So now when I have to find out probability m given g comma probability of m given all the variables, probability of m given all the variables, it is equals to probability m given its Markov blanket. I have to look for the Markov blanket of m. Now can anyone tell me what is a Markov blanket? Anyone, guys, what is a Markov blanket? Anyone, what is a Markov blanket, if anyone knows? Anyone, guys? Okay, so if I talk about a node X, let's say I'm talking about a node X. This is a particular node X. I have to talk about its Markov blanket, right? Its Markov blanket. So it includes parents of X, children's of X, children's of X, any another node, parents of X, children's of X, and it would take parents of, or I can say that other parents of children of X. So in this case, let's talk about this M node. So in this case, I can say that probability X given all nodes or all variables, all nodes is equals to probability X given its Markov blanket. So I do not have to take consider all the nodes here, right? Parents of X, children's of X, and other parents of children's of X. Now, if you would go back, if you would see here, what are the parents of X? M does not have any parent, right? M does not have any parent. If you would take children's of X, so I and G are children's of X, right? Now you have taken, so if I'll include I and G are children's of X, and it does not have any parent of X. We do not have that. Now we have to take parents of children's of X. So children's of X are those who, like, what nodes are the parents of these two nodes? That is B. So I'll take this B. So that means I can write down here probability M given I comma G comma B. Right? So I can write down this. Do you get it, guys? So for any node, I can do that. For any node in a Bayesian network. So if you would see your last one, it is true. Third one is true. Everyone gets it that why this third one is true? Let me know, guys, if there is any confusion in this question. Anyone in chat section, guys? Anyone has any question? If not, then we'll move to next question. That is, you have to calculate the probability of this probability B comma I negation of M comma G comma J. Let's take this figure into consideration. I'll copy this. Now let's find out the probability. Tell me, guys, what would be the probability here? In chat section, just let me know. So how do you find out this probability? Probability of B comma I comma negation of M comma G comma J. So you would start with this J. So this J depends on G. Probability J given G into this G depends on B comma I comma M. Right? B comma I comma M. But we have given Bi comma negation M. B comma I comma negation of M. Right? Now, if I'll move to this B, probability of B, and B depends on, sorry, I have to take here, instead of B, what would I take? I'll take here probability of I, because I's depend on B and M. And we have given negation of M, that means not negation of M. And probability of I, sorry, probability of B and probability of negation M. Now you can calculate the probability. So does everyone knows how to write down this? Just let me know, guys, if anybody doesn't know how to write down this. I'll discuss that in detail. If you know, then you can solve the probability. Okay. Okay, let's discuss this, guys, how we get this. Let's see how we get this. So here, if you would see, if I'll write down like for each node, you can write down this as probable. Let's say you would start with any of the node. You can start with B, I, negation M, G, J. So I'm starting with this J. So you can write down this as probability J given G, comma, negation M, comma, I, comma, B. Can I write down this? Then I'll write down probability of G given. So basically, guys, do you know Bayes theorem? What Bayes or law of total probability? Basically, law of total probability or this thing, it would tell you that if you have to find out probability A, comma, B, comma, C, then you can find out probability A given B, comma, C into probability of B given C into probability of C, right? So you would take each node at a time and then solving. So I have taken J, and then all the nodes I have taken now G, then I have taken all the nodes negation M, I, B, and then I am taking probability of I given negation M, comma, B, and then probability of B given negation M into probability of negation. I was doing that. Now this J, I told you, if G is given, no matter whatever the value of BIM would take. So I can write down this as probability J given G into probability of G. G, now you can see that G is dependent on I, B, and M. So I have to consider all the values, negation M, I, and B. And then I is dependent on negation M or B. So I have to consider negation M, comma, B. But here B is not independent on M. So in B given negation M would always be equals to probability of B and then probability of negation M. So that's how you get this formula, right? That's how we get this formula. Now let's put all the values. J given J. So J is true, G is true. When G is true, probability of J is 0.9 into G. So you have to take that M is false, I is true, B is true. So that means this one, this part, right? So what is the probability? 0.8. Then I given negation M, comma, B. M is false, B is true. That means this one. That is 0.5. Probability of B is 0.9 and probability of M is given to me 0.1. Probability of negation M would be 0.9. So I hope you guys get it, that how we get this probability. Now you can calculate it using calculator. Just let me know, guys, if there is any confusion or question in this. Yeah, we'll get the probability 0.2916. What is the value of negation M? So basically, when I'm writing small m, that means I'm taking it as true. When I'm taking negation of M, that is false. Now, if I'm writing capital M, now capital M can be true or false. Small m is true, negation M is false. Right? That's how I basically represent. Just tell me, guys, if this thing clear. Should I round off? Arvind is asking. So it depends on the question. It depends on the question. And the probability of negation M is zero point 0.9, right, Arvind? So how do you find out that probability of M is given to me 0.1, right? That means M is true here. So if I have to find out probability of negation M, that would be zero point 0.9. Okay, now next question is basically based on variable elimination. It says that calculate the probability that someone goes to jail given that they broke the law, have been indicted, and face a politically motivated prosecutor. So basically, this BIMGJ here represents that it gives given goes to jail. Let me just copy this diagram. Just a minute on the next page. Right. So now I assume you guys are able to see the image. Yeah. Now, someone goes to jail. That means they are talking about capital J. So basically, when you have given probability B given J, comma I, comma M, this kind of thing, then you have to use Markov blanket. Otherwise, you do not need to use Markov blanket, right? So here you can see that you do not have used Markov blanket here, right? When solving the question, like to find out, you have to find out this probability. So there is no need to use Markov blanket, right? If we have given all the notes and then uh, you have to restrict for some notes, then you have to use Markov blanket. So you can see that if you would use Markov blanket in this, you have given all the notes J, G, M, I, B. But if you would see, now its Markov blanket has only G, because you can see that the parents of J are G is G, and no children and no children parents. Now if I'll go to this G given negation M, comma I, comma B. Now you can see that there is not all nodes. It does not have all the nodes, right? It does not have all the nodes. So I'll not going to use Markov blanket here, because where to use Markov blanket? Markov blanket says that probability of X given all nodes of your Bayesian networks is equals to probability X given Markov blanket. Markov blanket. Right? So when you have given all nodes, then you can use your Markov blanket. Otherwise, you cannot use Markov blanket. Otherwise, you would use the basic statement which we know about the Bayesian network, that a node X is conditionally independent of its non-descendant given its parents. Right? What does it mean? So if you would see here, you can see that its G parents are B, comma I, comma M. So it is dependent on only on these values. If I'll see I given, if you would see that this one, probability J given G negation M, comma I, comma B. So you need only G here, right? If I'll not go for Markov blanket, I'll need only G, because given its parent, a node X is conditionally independent of all its non-descendants. Like these are its non-descendants. It is not coming from them given its parents, right? So we have given J is parent G, so it does not depend on any another node. Is it clear, guys? Where to use Markov blanket? Ajay, is it clear where to use Markov blanket? So Markov blanket says that probability X given all nodes equals to probability X given Markov blanket, right? So when we have all nodes and we have to make it precise, then I'm going to use Markov blanket. Otherwise, I'm going to remember the statement that probability of a node given its parents is conditionally independent of all its non-descendants. Is it clear, guys? Just let me know if there is any confusion or question. Okay. So basically, guys, I am saying that probability, what does your Markov blanket says that? Markov blanket says that probability x given all nodes is equals to probability x given Markov blanket, right? So if we have all the nodes given and they're asking for the probability of a particular node, then to decrease the number of nodes, I can use its Markov blanket. I can use Markov blanket if I have all the nodes given, right? Then it would be given its Markov blanket. But at the same time, if I have uh, if I have nodes, right? But if I do not have all the nodes, here you can see that if I take this probability G given negation M comma I comma B, here there is no point of considering Markov blanket because Markov blanket only works when we have any node X given all nodes, probability X given all nodes. So here Markov blanket does not work because you would say that probability X given all nodes would become probability, there would be G as well because the children of G would be J, right? Children is J. That is under Markov blanket, but that is not here. So Markov blanket only works when we have given probability X given all nodes, right? If I want to probability of any particular node and they have given all the nodes, then I have to use Markov blanket. Otherwise, I have one statement which helps me to solve the problem, which is a node X is conditionally independent given its parents of all its non-descendants, right? If a particular parent is given for a node, then no matter what, all other non-descendants are taking the values, right? Here, if I know what the value of G is, no matter what are the values of B, comma, I, comma, and J is only dependent on G. Do you get it now? Tell me, guys, if there is still any confusion. Okay, so yeah, let's solve this question. Now they're asking calculate the probability that someone goes to jail given that they broke the law, that means B, goes to jail, that means J, broke the law, that means B, have been indicted, that means I, face a politically motivated prosecutor. Now, if you would see here, they are asking to find out probability J given B, comma I, comma M. Now you can see that its parent is not given, G is not given. So you have to solve it completely, right? Now you have to solve it completely. And how would you solve this? Now, because they are asking me for the probability of J given B, comma I, comma M. So if you would see, I'm writing here. Can I write down here? Small b, small I, small m. That means because they broke the law, B, capital B is true. They have been indicted and capital M is true. B, comma I, comma M. Can I do that? Probability J, comma B, comma I, comma M. Now what would I can write down? Because uh, I can write using variable elimination. First step is I'll write down probability J, comma B, comma I, comma M summation, and I'll take here alpha, not summation. I can write down this as alpha into probability J, comma B, comma I, comma M. Guys, do you know why I am multiplying it by alpha? Do you guys know? Anyone? Basically, what is your A given B? Probability A given B is basically probability A comma B, or you can say that A intersection B upon probability of B. So 1 by probability of B I have taken as alpha. I'll replace it with later, right? What would I do? I'll take sum of all the probabilities and divide it. Now, once I got this alpha into probability J, comma B, comma I, comma M, I can see that it does not include the value G. So what would I do? I'll write down here alpha summation, and I'll apply summation on capital G, J, comma B, comma I, comma M, and I'll add capital G here. Now capital G can take values true and false. Both values it would take. Now, if you would write down using this as chain rule, what it would become? Summation capital G, probability J given capital G into probability of G given B, comma I, comma M, into probability of B given I into probability of M given I. Sorry. Yeah, I can write down this as probability B given, or I have written it in a wrong way. Alternatively. Right. It would be probability because I is dependent on B comma M. B comma M into probability of B into probability of M. Do you get it, guys? Just tell me if this thing is clear. Now, what would I do here? Let's take this summation J inside, whatever it is required, and take the constant outside. So this would be constant IBM because summation is only on G. So I'll take this outside probability I given B comma M into probability of B into probability of M. Now I'll write down summation of G, probability J given G into probability G given B comma I comma M. Right? But I is true, why calculate I given B comma M? No, I'm not calculating. I have just taken all the values outside. I'll take, right. I is given to me true. Right. Uh, right. You can remove that. You can remove that because obviously at the end we are going to add, we are going to rationalize it using alpha. We are going to make a balance using alpha. But right now, let's say I'm writing it. Let's say I'm writing it. We'll see that if we need to remove it, right? We can remove that as well. It's up to you. Uh, yeah. So let's see. Let me make some space on the next slide. Yeah. Now I have to solve this part. Now you can see that it would be a function of G. What it would be? What it would be? It would be a function of J and G. It would be a function of J and G. So if I'll take a small part of this, if I'll calculate this probability G given B comma I comma M, that means I want to calculate probability, probability capital G given B comma I comma M. And you can know that B, I and M are true. If B, I, M and are true, B, I, M are true, then what is the probability of G is zero point 0.9. Now this G can be true or false. Now this probability, this G can be true or false. So that means probability G given B comma I comma M would be, if capital G is true, it is zero point 0.9. If capital G is true, it is zero point 0.9 and otherwise it is zero point 0.1. Right? So this I can say that this is what? This is my, can I take this as F1G? F1G, right? And if you would say probability J given G, that is given here. If G is true, then it is zero point 0.9. If it is false, that is 0. Now, if I'll take this whole function and consider this as F2G, what is this F2G here? If you would see this F2G, would it be F2G or F2J? It would be F2J, right? Why it would be F2J? Because you would add summation on G here, right? You would take summation on G, then G gets replaced. What is your F2J? Summation probability J given G, J given capital G, G can be true or false, and into probability G given B comma I comma M. Small b I am writing, all would be true, right? Now what it would be? Probability J given G. Can you write down this as probability small j? You have to find out probability of J given Can you write down this as, let's write down this as probability J given small g into probabilities G given B comma I comma M plus probability of J given negation of G and into probability of negation G comma B comma I comma M. Right? Can I write down this? So if you would see that probability J given G, probability J given G, G is true, that is 0.9, 0.9 into probability G given B comma I comma M, that is 0.9 plus probability J given negation of G, that is 0, that is 0 into probability of negation G given B comma I comma M, 0.1. So we get this as 0.81. So this is a probability you get for this whole function F2J. F2J is your 0.81, right? F2J is your 0.81. Now you can put down all the probabilities I, B, M, B, comma M, right? You can write down this probability. Just a minute, J given negation of G, that is 0.1, 0.1. Why it is 0.1? Because you want that probability J given negation of G, J, that is true, that is 0, right? That is 0, that was correct. This is 0.81. Now, similarly, can you find out probability F2 negation of J? If it is negation of J, can you find out negation of J? Then what it would be? J would gets replaced with negation of J. J gets replaced with negation of J. Negation J given G into probability G given B comma I comma M. Everything else remains same. Into probability plus probability J given negation of G into probability negation G comma B comma I comma M. Now you would say that, ma'am, why would we calculating F2 negation of J as well? Right? Because I have to remove this alpha. So now from here, what would you get? Let's solve this. Negation J given G, it would be 0.1 into 0.9, that is 1 into 0.1. So if you would solve this this is plus. If you would solve this, probability would be 0.09. So it would become 0.19, right? 0.81 into 0.19. Obviously, it adds to 1. Now, probability I given B comma M, if you would write down this as alpha, probability I given B comma M is zero point 0.9 into probability B 0.9 into zero point 0.1. And we have probability of J and 0.81 and 0.19. 0.81, 0.19, right? So this is for J and this is for negation of J. So now you would multiply this, and if you would add both the probabilities and divide it by one of the probability of the numerator, you would get the value probability J given B comma I comma M, and that you get similar as 0.81 and 0.19. So this probability basically it would be 0.81 on solving, right? Do you guys get it? So basically, what we are doing, we are eliminating the variable and solving each of the parts. So first we have solved G given B comma I comma M, and then we have solved the summation, right? And after solving the summation to find out the value of alpha, we have to solve it completely so that we are able to find out the value of alpha as well from here. But in this case, in this particular case, you can solve this value by you solving this only, because if you would see what they were asking probability J given B comma I comma M, right? So you can write down this as, because now everything else is given, J true, B true, I true, M true, and you can write down this as only thing that is not given to you, that is G, right? So G can be true, G can be false. So you have to add that variable. So that's why we have done that probability J comma B comma I comma M comma capital G, right? Then you have to take the summation over G. And G can be true or false, right? So this part only would give you the answer, this part only. But yeah, I told you this whole part, that how this, you would write down this as J comma B comma I comma M comma G, and then you would solve the probability, right? So just try to solve some more question. Let me share some questions with you. Uh, so this is one of the question. Just try this question by yourself. If you do not get it, then we are going to discuss it in the next class. Just a minute. Yeah. So, okay, just give me a minute. Let me copy one question and share it with you. Just give me a minute. Okay, what is happening? Yeah, now it's visible. Huh. This question you have to solve by yourself. Okay, let's do one thing. I'll bring more questions based on this variable elimination because you guys are facing confusion in this particular topic. So we are going to discuss more questions on variable elimination. Till then, just go through once and go through the topic of variable elimination. So in tomorrow's lecture, what we are going to do, we are going to discuss this particular topic in detail, right? But before that, let's try to solve this question. This is not of variable elimination. This is simple question. Okay, just try this by yourself, right? Because time is not enough. So what we are going to do in the next class, we are going to complete this question, right? Not this particular question. We are going to complete a topic that is variable elimination. Is there anyone else has any question? Just go through this particular topic once, variable elimination, and then we are going to discuss more questions based on it. Okay, so yeah, that's all for this session. Guys, we are in short of time, but we are going to continue in the next session. All of your doubts, all of the questions, if we have left, right? So let's continue in the next session. Thank you, guys. Thank you for joining.